I passed. Good afternoon. My name is Kevin O'Connor from Axalta Coating Systems. Very happy to be here. Very happy to talk about an exciting topic of collaboration, something that has been mentioned several times this morning throughout the presentations. And at least for me, when I think about collaboration, I think about the challenges our industry faces. And they're not getting easier. They're getting far more complex, more multifaceted, and more, there's a need to think about outside of our building and the competencies that we have to find solutions to these challenging problems. So I think this topic is pertinent, leveraging university collaborations. And fortunately, we have four experts in this field, very well versed in collaborations from a variety of industries and academia, and expect an interesting discussion. So if you have questions, you can pose them via the app. I believe you can also raise your hand and there might be a microphone floating around the room. But I encourage you to ask questions. Should be a good discussion. So let me get quickly into introductions and I'll make sure to leave a lot of time for questions. So starting off on the far end, Dr. Dean Webster, actually almost the far end, he spoke this morning. Dr. Webster is professor and chair in the Department of Coatings and Polymeric Materials at North Dakota State University. He received his Bachelor of Science in Chemistry and PhD in Materials Engineering Science, both from Virginia Tech. Prior to joining NDSU in 2001, he worked for Sherwin-Williams and Eastman Chemical Company. He was named Fellow of the American Chemical Society in 2016 and a Fellow of the National Association of Inventors in 2024. His research is in the area of new high-performance polymer systems for coatings and composites, high-throughput methods, marine anti-fouling coatings, anti-icing coatings, which he talked about briefly this morning, and the use of renewable resources in polymers and coating systems. Thanks for joining us, Dr. Webster. Right to my left here from Axalta, Dr. Florangel Perez. Dr. Perez is VP Technology and Strategy and Raw Materials Technology with Axalta Coating Systems. 7 years with Axalta, Dr. Perez has held a number of different roles, including Electrocoat Technology Leader and Formulation Development Team Leader. Before joining Axalta, Dr. Perez had numerous leadership roles at both AkzoNobel and AB InBev. Dr. Perez holds a PhD in inorganic chemistry and a minor in material science and engineering from Cornell. Dr. Jay Guo from the University of Michigan. Dr. Guo started his academic career at the University of Michigan in 1999 and has been a full professor of electrical engineering and computer science since 2011, supporting applied physics, mechanical engineering, macromolecular science, and engineering. He has over 230 journal publications with over 25,000 citations. Professor Guo's research includes hybrid photovoltaics and photodetectors, polymer-based photonic devices and sensor applications, flexible transparent conductors, plasmonic and nanophotonics, nanoimprinting, which we talked about a little bit at lunch, and roll-to-roll nanomanufacturing technologies. Thanks for joining us. And Dr. Niamh Hosking from Ford. Niamh is a manager of the Coatings and Surface Research Team at Ford Motor Company. Her technical background is in corrosion mechanisms of lightweight automotive materials. She has over 25 years in automotive experience, having worked for both Ford in the UK, Germany, and Australia. Before moving to the US in 2013, Niamh graduated from the University of Nottingham with a PhD in materials and mechanical engineering and has a Bachelor of Mechanical Engineering from the University of Limerick in her native Ireland. Thanks for joining us as well. Okay, so let me check to see if there's any questions. If not, I have several of my own to get the ball rolling here. So maybe if we start from the top, 30,000 feet. I mean, many of us in theory are familiar with this idea of collaborations, but maybe Dr. Webster, will start with you. How do we get started in these collaborations? And more specifically, is it always industry reaching out to universities, or does it ever happen in reverse?
Okay, very interesting question. How do you get started? Well, you get started having a discussion. And actually, I found an awful lot of collaborations can start with a meeting like this, and you give some presentation on what you do, and then you have some discussion on the side, and then you go from there. Maybe the company expresses a need and says, you know, what do you think about this or this problem? What ideas might you have? So really, it just starts with having conversations. There's probably a lot of, most of mine have been industry reaching out to us because they'll recognize what expertise and maybe what thing we could fill in that they're not able to do. But in the case of our center, we often reach out to other companies to become members of that center. So it can go both ways.
Good. Thank you. I think you were alluding to there a little bit the idea, at least this morning, of consortiums as well. So there are several groups in here. It's not just academia and industry and government, but there are consortiums as well, kind of a fourth partner, if you will. The inevitable question about IP ownership. And the specific question is, how is IP ownership handled in university or industry collaborations? And maybe if this person doesn't mind, I'll frame it differently. How is it handled well? How is it handled in a manner where it ends up being, in a sense, a win-win and kind of all the challenges are alleviated? I'll leave it open to anybody if you'd like to take a stab at it.
I can talk a bit. Yeah, the University of Michigan, now we have a pretty uniform sort of policy, you know. So when the research agreement is signed before our university and the industrial partner, basically is that if the technology is co-developed, you know, contribution come from both sides, it will be jointly owned. If it's purely developed by the PI and the students, that's going to be owned by U of M. Otherwise, it's going to be owned by industry. I think in the collaborations I have so far, we either have the co-owned IPs or the solely owned by U of M.
Got it. Thank you. Anything else to add?
I'll add, again, there's most public universities, a lot of companies come and they're like, if we sponsor the project, we want you to assign the IP to us. Most public universities aren't able to do that just based on policy and governance. And so I think part of it is just having that discussion that inventorship or ownership should follow inventorship. So if the inventor is at the university, then the ownership vests with the university, and with the company, then the company. And again, with joint IP, if really it's co-developed and that's jointly owned. A lot of universities, I know we several years ago instituted a capability of negotiating the licensing terms at the front of the project. So that everyone just knows when IP is identified, what those terms will be and how that will be handled. And so there are no unknowns. And our previous policy was they didn't want to negotiate licensing until the project ended. And that just created so much uncertainty as to what would happen. So the ability to be able to just have that all laid out before the project even starts, I think just helps everyone understand what's going to happen if the project's successful.
I agree with that comment. Having that discussion up front, and actually some of the templates help, because before we even enter into a discussion around possible collaboration with university or any entity, we always have to have that up front. What are your expectations? What are ours? Because as you say, when you're already down the road and already created the IP, that's the most difficult if you're now negotiating. So having that up front helps quite a lot.
I think the ways to avoid, exactly like I said, getting into that situation are to be very clear up front. And also it takes getting the right people engaged from both sides. So and you said that the university has a policy. Well, you can be sure that the industrial partner has a policy. And as long as they can be aligned, everything is hunky-dory. But it does take a lot of thoughtfulness and effort and time to get the right framework and make good upfront decisions about what you expect to come out of it and make sure your expectations are aligned.
Yeah, and I think maybe just a last comment here, one of the things that really is also important here is, what do you hope to get from that collaboration or that partnership? If you know upfront what you need, then you could start to build that into the initial discussions, right? I mean, if you know that, okay, I'm doing this work with this group because this is part of our roadmap, we want to come up with a product, then that should be known, or at least you should have that consciously working with your lawyers or in the other group's lawyers to understand this is really what we're looking for, what we're after. Oh, I'm sorry. Yes, sure.
So I do have some other questions here, but if you have questions within the room, I believe you have a microphone, so feel free to raise your hand and we'll call you out. So one of the things we talked about, a few of us met for dinner yesterday, what good collaboration looks like, what it looks like, what it doesn't look like. And we talked a little about kind of the cadence and what makes for a fruitful collaboration in terms of how often you interact. So maybe a question for the group here. What does that cadence look like? Is it we agree on terms, we meet a year later? Is it we agree on terms, we meet every day? What does a successful collaboration look like in the sense of how often you engage?
I think like anything else, a more frequent discussion is always helpful, right? Know each other's need. Like I can give well, it's not from me though. The example, let's say, many years ago when we initially work on so-called structural color, we had a collaboration sponsorship from the Samsung, from Korea. I found it very, very helpful. We otherwise would just work on academic aspect. They will tell us, if we can actually manufacture what you are discovering or making, right? It has to satisfy this and this requirement. Kevin, you were working on PVD before. I still remember one thing they told me that, okay, for this film, right, you have to allow about 10% variation, right, in your design. Otherwise, just it won't happen in reality. So I think those things are extremely helpful for us, give us a boundary.
Yeah, I think one of the examples brought up when we were kind of meeting yesterday, the idea is if the meeting is only at the front and then 6 months later, the amount of deviation that can occur and kind of going off script in a sense, and those touch points are important.
We've also set up collaborations where, like you said, the governance part is important when you start the work. And one of the things that I think worked very well for us with Axalta and some of our collaborators really is to set it up so that the initial part, you actually meet more often, because that's when you get to know and get to learn a little bit more details about the systems that you're working on, as well as how each group want to work, right? And if it's with a university where there might be a graduate student involved, inviting them over so they could actually work in our laboratory, or us visiting them in their laboratory to see what are the needs of each of the parties, right? Providing them the necessary equipment, materials, that kind of a thing. But then after that, then you start to taper off, and you get to learn what works for each of the groups, right? It's difficult for any of us to be on a call every week, but every other week for the beginning, and then maybe once a month, but not less frequent than once a month is what I find to be very helpful.
Yeah, we have a similar kind of approach. And the important bit is that it really takes effort on the industrial partners side, as well as on, the students and the primary investigators at the universities who, are doing the work really, but without the kind of guidance, the inputs on boundary conditions, the work is not going to be fruitful. And on the industrial person side, they need the time also to dedicate to it. And I mean, a real challenge for people in industry is many of us have very, very full plates. So you've got to be strategic about what projects you support, what you commit to, and make sure that you are, you know, you have the bandwidth and the right people in the team to, yeah, make it a successful project.
Yeah,
Thank you.
no,
Just go ahead.
throw in one again. I think monthly updates is really pretty practical because one of the things that does is it makes you step back and organize what you've done and see where you've been, because sometimes in academia we go off in all these different directions, and it's just useful to have to sit down and say, okay, what did we accomplish? What are the experiments? What were the results? And put them in some organized form. The one thing I liked when we had the project I mentioned this morning with Covestro is we would have meetings once a month with at least the folks in Pittsburgh. But then periodically, and I forget exactly if there was a specific schedule, we would have a meeting that was a little more comprehensive. So maybe quarterly, we would have an update of the quarter, but then include the folks over in Germany and some more upper level management. And so you could get feedback from different levels in terms of what your progress was, what they thought you should be doing, not doing. So that was useful too.
I think another important part is, you know, understanding what success looks like. I think you gave a really nice example this morning. You talked about, you know, you try this experiment, you know, this might work, and you found out it didn't. But by the way, you know, you found out some other really interesting stuff. So I think with university research, where you are trying to be, you know, open to creativity, new ways of looking at things, it's like not something that lends itself, at least I think, to, you know, an automotive product that, you know, needs to be on a car. Like, that's not the measure of success. You do not want to be on the hook for delivering a product or a process or a material tied to, you know, Ford Motor Company's next Mustang. That is not a comfortable position. But, you know, looking at a problem in a new way, trying something out, even if it doesn't work, you know, that's so valuable still. And, you know, more students who should publish more stuff about things that don't work. So, you know, 20 other students don't repeat the same experiment. It's important that, you know, ruling things out is also a success.
Well, and I think on that project, we had all these reaction products that were not what we were trying to get. And it was the folks at the company that said, wait a minute, but you've got a new synthesis route for these compounds. And it was like, okay, so there's a win. Even though we didn't get what we were aiming at, we still came up with something new.
Yeah.
Great, thank you. Another question, I think this one a pretty obvious question, and unfortunately, we don't have anybody from government on this panel. That would kind of have it well balanced. The question is, do you see changes in government funding for research with the current administration, like reducing projects on climate change or the effects of US tariffs?
I want to know the answer to that.
Sorry.
I want to know the answer.
Yeah, well, maybe for next year we'll have that particular person here, but maybe we'll start off with two colleagues from academia.
Well, we've already seen you know, big cut from agencies like NIH, right, DOE, and now we even get into NSF. So it creates a lot of I'll say headache, at least, right, to the university and administrators, as well as to many faculty. The University of Michigan, you know, actually have some emergency plan to come up with some emergency money to cover. I think last thing I saw is they can cover up to 6 months. But beyond that, it's totally unknown. Yeah, I think this is creating a lot of uncertainty. In fact, it even affect our recruitment of the next batch of students. Yeah, so many programs are very conservative. We are told, right, to be conservative because even you bring the student in, how are you going to support them, right? I mean, this is a reality right now. Yeah.
I think there are new policies coming down on high but there's a lot of uncertainties about how all of these are going to be implemented in the different agencies. And so hopefully as the agencies have to grapple with some of the newer policies, they'll be able to develop the procedures and things that they're going to follow. And it may just shift sort of the focus of the research. I mean, one of the rationales that you hear for why they're reducing indirect costs on grants is so that there'd be more money for fund more programs. But of course, that remains to be seen at this point.
Maybe a related question, but phrased somewhat differently. So that's with respect to government funding, the idea of what projects, but I guess in industry, we also pick our projects to work on. And some of them are tied to policy. I guess how might we manage between Ford and Axalta which projects we work on, given the shifting in preference of government?
I'll try. Important caveat, personal opinion, not necessarily representing Ford Motor Company or Ford Motor Company's position. I mean, a lot of the things we work on in research are, further out. So our timescales are, longer than 4 years or a current administration. But there are definitely, changes, and we are in some turmoil right now between tariffs and changing, priorities on what are really going to be something like government policies on EV, rebates or material, like hazardous material requirements, or net zero targets. I think when the targets are super far out, you need to have a defined path to get there, and those are like 10, 15, 20-year long paths. So something that happens today doesn't necessarily, divert you too much, and you have time to respond. But I think it is very challenging for the people who have that responsibility to map that path forward right now. They're also dealing with, a lot of uncertainty.
Where the policy certainly has a lot more impact on what we do in industry is more around prioritization, that I would say, right? So for example, if you know that our legislation is coming down to ban a particular material that is used in our processes or in our systems, then obviously we all shift focus to make sure that we meet that legislation requirements. And that might mean sacrificing the longer term programs that we may have in order to get to the answer that we need today, right? And that also affects then if we're funding, which for example, Axalta funds a lot of our external collaborations from internal money. We don't take government grants or anything like that. Then that of course affects the pool of money that goes to external collaborations. So that's more of an impact.
Yeah, thanks for answering that directly too, because that was, more specifically part of the challenges. A lot of our technologies generally, that might be related to climate and this idea of net zero, but the short versus long-term trade-off. So I appreciate it.
The other point there is that we are, global companies. So if there's a very different policy in Europe or a different part of the world, I mean, you have to manage that too.
Yes.
Yeah.
Great point. Maybe a question for Dr. Webster and Dr. Guo. You're in an interesting position that you deal potentially with many different industries, exposure to a lot of different type of technologies. The question is, where's the question? There we are. Does the university use knowledge developed in collaborations with one company in projects with other companies? And maybe if the answer is yes, perhaps if there is an example that you're allowed to share. By the way, I'm ad-libbing a little bit from this question, but.
So I think the question is, if we have university developed technology, then do we go forward with companies?
Yeah, so for example, if you were working with BASF on a project, there's some very interesting learnings, but 3 years later, it's completely different industry, another
Okay.
potential client, and there's something that's a leverage there.
Yeah, and I think that you have to think about sort of relationships that you have with the companies and whatever boundaries you might have with them. So I would say probably if I had developed the technology with one company and then several years later we saw that technology could be useful as starting another project with another company, I'd probably go to the first company and make sure they were okay with that. Just because you just want to keep people in the loop. Because you wouldn't want of them all of a sudden to hear that that technology that they thought they had a role in was being used by somebody else and they weren't aware of that. So I think just keeping the communications open, I think, is the way to deal with that situation.
Okay, thank you. Dr. Guo?
Yeah, I have to think a bit of your question because as far as I remember, we worked with many companies before, but the project was relatively short term, maximum one year. And once the goal is accomplished, we would just move on to new things. I haven't experienced anything that, we develop with one company, we have to apply, or we will apply to another company. So it didn't apply to my case, yes.
Okay, thank you.
Mhm.
Another question here, reading it verbatim. Generally, industry wouldn't spend any dollars without a clear path for return on investment. What % of collaborative projects are successful by this standard? Maybe I'll start with my colleague here to my left, Dr. Perez.
Boy, I don't know what, that I could say that it's, that none of them are, I think we think about industrial, academic collaborations as you define what is it that you hope to achieve up front, right? Like you said, if you don't want to be in that project where you're supposed to be delivering the Ford Mach-E next year, we pick the right people to do those kinds of work, and not the academia collaboration is. So I would say all the projects that we work with in academia have a return, whether that return is a fundamental understanding of a problem that we are working on. It may not be a product, or you may not be able to measure it from that point of view of product in 2 years, but we know we will have that return later on. So a good example, I don't know, Kevin, you're involved in NextJet, of course, which is Axalta's digital paints technology. That's one of the beginnings of that project, is a collaboration with university in trying to define what kind of rheological characteristics would we need in the paint. Now, that was maybe 10 years ago. Do we say that was not successful because we didn't come up with that paint 10 years, 11 years, or sorry, 9 years ago? No, we said that was foundational for us, because based on that work, we came up with a group of patents that we are now working towards commercialization. So it's hard to say that there's no return. That's just not how you want to measure the academic industrial collaboration. I know what your thoughts are there.
Well, I agree with what you were saying. And I was just thinking about, as an example, our group has been involved in the iPrime consortium that Dean was mentioned this morning. And it's like you were saying, it's not really easy. And I'm not a bean counter, so I'm not excited by return on investment. There are other people who concern themselves with that. I'm in research and trying to learn things. But through something like iPrime, you can, or similar projects, the 10x that you get from participating in that does give a return on investment for sure. In that space, we're interested in, battery coatings, for example. And this is a very high intensity kind of competitive area. So it is not something that we would necessarily want to work with outside partners on in some ways, but in some ways we do. So it's very strategic where you leverage the university project, where you leverage like a consortium, what partners you choose to work with, you know, what other suppliers you work with, in order to, you know, get the maximum return on your investment, which, you know, besides the fee they might charge you, will also be the, you know, researchers, the scientists, the engineers' time, which I think is far more, that goes into making a project successful and taking whatever learnings you get from that and turning it into, you know, real product value, which may take, like Angel said, like 10 years later. Yeah.
Thank you. So speaking of 10 years, the next question is, how long is a typical industry university collaborative project? How long should they be?
I'm gonna give a quick answer to that. It should be as long as it should be. It should be very specific. At Ford, we had a quite rigid system for university research proposals. It was very rigid. And thankfully, it was recognized that that was not the smartest way to do this. So more recently, we've had a lot more flexibility to stand up a project, whether it's, you know, 3 intense months to, you know, get some work that a university can look at a problem and give us a kind of fail fast or succeed quickly, look, see, or whether it's, you know, a 3-year program that, you know, gets renewed year after year thereafter. It should be as appropriate for the question in hand.
Yeah, I of course agree with that.
The longer the better, right?
Well, yeah, it depends. So I mean, part of it's going to depend on what the goals and objectives of the project are and what the pacing should be for the work. I would probably say many of the industry projects I've had have been a 1 to 2 year type project. And I've also tended to use like postdocs for those types of projects rather than students, because students have divided attention, and it can be sometimes a little difficult to have a student on a project that has like deliverables and milestones and things, whereas, you know, with a permanent or a staff person that's dedicated to that project, they can be much more productive. But you know, again, it's useful, you know, to think about, you know, maybe a multi-year project, but maybe you have sort of a go, no go each year as to whether you're going to continue in the next year, or the possibility of you get good results in the first year and there's more work to be done. So, you know, it can be extended to another year with additional funding. So there's lots of options there.
How do you manage the dialogue? So with somebody from industry, I mean, when I hear these answers, my initial instinct is there's got to be timelines. It's got to be short. We need to be aggressive. But at the same time, for doing some of the fundamental work that you're doing, that may not work well. I guess, how might you manage that dialogue with potentially somebody in industry who's given aggressive timelines, and maybe your feeling is that it might backfire? How do you navigate that discussion?
I mean, so a lot of that has to do with that initial relationship and the initial discussion of the project and the project scope and what the expectations are. I think, again, having people feel flexible, that again, you may not be able to, you know, get as much done as you thought in a given period of time for various reasons, or, you know, again, maybe you find that the research takes you in a different direction. So I think a lot of it just depends on having a good relationship back and forth, so that if things come up, you can discuss those and decide what the path forward is. And again, having some flexibility in the timeline of the program and maybe what the goals and objectives are.
Yeah, I do agree. And really, Kevin, it's not any different than how we run our projects.
Okay.
So upfront, we develop a scope of work. We decide what the milestones are. And because we talk to each other very often, we know where the project is and how what's the probability that we would meet the next milestone. And if that's the case, if we do, then great. If not, then we think about how do we make adjustments, right? But that's same thing as how we would run other projects.
Got it. Thank you.
And the silver lining of the COVID pandemic is that we all learned that actually you can be more flexible than people thought before. So I think maintaining that is important. And the other part is it's really a learned skill. You know, you got to practice, and hopefully you get better every time you do it.
Thank you. Next question, I think, is a great question. Many companies in here, many big companies, bigger universities, but you know, innovation kind of pertains to everybody here, including the smaller companies, smaller revenue size, but just as innovative. And the question is, larger industry and university partnerships are common. How should a smaller company go about starting a partnership? Are there funding or TAM minimums, TAM minimums? So if you, for example, there's a lot of companies in this room right here that are very innovative people, great ideas, but maybe don't have the bandwidth they're looking to collaborate with the university. How might they go about? Is it possible?
Well, there's, again, if the company has fewer than 500 employees, you can apply for SBIR grants. And every government funding agency has SBIR program by mandate. And so, again, that's where the company and the university could go together and find an appropriate project. Sometimes you can talk to the program officers about, you know, what you want to do. With DoD SBIRs, they tend to run 2 solicitations a year with very focused topics. But with the National Science Foundation SBIR program, those are very open-ended. And as long as you've got something interesting to work on, you can submit proposals to that. So that's a good way for a smaller company to leverage government funds and then university expertise.
Actually, Dean, you also mentioned this with the consortium, right? Where in some consortiums, of course, sometimes you pay in a number of people to be part of that consortium, but others actually also would accept in kind, right? And that's just not true for US. Other countries, they do the same thing, where you may have an institute soliciting some other like entities like industry to join that group or that funding for that particular project. And the funding could take the form of money, or it could take the form of somebody's expertise, you know, lending your time, or materials. So there's a lots of ways for even smaller companies to participate.
Great. I do have a few more questions here, but again, if you do have a question that you'd like to ask in person, I think the microphone might be floating around. I will ask all 4 panel members this question next, because I think it's a really good question. Starting with Dr. Guo, can you tell us about a current project that you're really excited about? Something new in the next year or 2?
I can think about a couple of them. Yeah, there is one technology that actually sponsored by a company from a couple of years ago. We're developing, it's not in the automobile sector, but display, specifically micro LED display that's projected to be the next generation to after OLED. But the biggest challenge is to how do you use a high throughput, low cost way of anchoring those LEDs into the specific point. And typical, you know, right now is a pick and place. It's very, very slow and very costly. So we're developing a kind of a new fluidic assembly technique. And during the first year when we were founded, actually the progress has been relatively slow. But you know, mostly after the funding is almost ending, at the particular week, we have some very interesting finding, and it works so beautifully right now. And so we're hoping that it leads to something useful in the future. Yeah, so that's one of the
Thank you.
Yeah.
Appreciate it. Dr. Webster?
Oh, probably. Again, this is a collaboration with what's called now Luna Labs. And this past year, we got a 1-year project to look at the feasibility of a concept to synthesize polyurethanes without using isocyanates anywhere in the process that then could be cured at ambient conditions. And I think we far exceeded the expectations of the initial 12 months. And so now we've already got approval for funding to continue the project and optimize things. So pretty excited about that because there's just a lot of potential there. people are concerned about isocyanates.
Thank you. Axalta is looking forward to an exclusive relationship on that. Joking. Dr. Hoskins?
We have a few ongoing at the moment. I'm gonna pick on one that's actually not in my technical area, so please, if you want more details, I will refer you to my colleague. AI and machine learning has, been highlighted as this is the way forward. Everybody's got to get on board. And we're fortunate in our team to have some people who are very smart and looking at these new tools and answering the question that we have, which is like, okay, where does it work and where does it work well and where is this, not the right path? So we have a project right now that's very interesting, that confuses me quite a lot because the concepts are pretty wrong. But basically, we want to take design of hoods and to be able to use a tool to automatically kind of morph the design and then give some attribute performance predictions about what it would be. So this would help our designers, not the aesthetic designers, the structural designers, play with geometries that they wouldn't have looked at before and predict, okay, how that is going to perform with respect to how it goes through our machine shop process, which is very cool and still TBD whether it will work or not. So we love projects like that where we get to learn a lot through the process, and maybe there'll be a useful tool at the end of it, or maybe we'll just find out this isn't the way to do this.
Not sure how much I can disclose, right?
Just make up the names.
No, but I mean, I think most people here are familiar with NextChat, and I'm certainly very happy about that project. I wasn't there at the very beginning, but I was certainly a part of that inception, and the fact that it's getting close to commercialization is exciting for my company, for Axalta. I'm sure Kevin is excited about that as well. But the other thing is, you had mentioned, the machine learning is definitely one that's forefront for us as well. Axalta has always had some programs around machine learning, big data, because of the predictive capability when it comes to color and color matching, right? And going beyond that, can you skip a lot of the iterative design experiments to get to a formulation that can deliver the properties of the paint, right? So if you think about how difficult that could be, because when you most people here, how many factors could affect the aesthetics of paint that's on your car, from the formulation, how it's put together, to the application conditions, and then finally what you measure or what you see. And if you can skip that whole middle part, or at least get close, right, that would be a great approach. And there's work that's going on now. Whether it would pay off in 2 years or maybe longer, that remains to be seen, but it's definitely an exciting area.
Thank you. I see the longer we're up here, the more questions are coming in. I apologize. We won't be able to get to all of them. So 2 more. I'm going to bring one here on the app, but if there's a question in the room, you'll get precedence. So let me know. First, starting with the app. There seems to be a big gap in the internship opportunities for PhD students compared to bachelor's degree students, where they prefer bachelor's. How can industry and academia bridge this gap to allow PhD students open to outside academia opportunities? Anybody on the panel?
Just let me know.
There's your answer.
I mean, if you want an internship with a PhD student, just let me know. We have students who are very interested in that. And again, those opportunities aren't as prevalent for graduate students as they are for undergrads.
Yeah, I don't know that there's anything stopping us in industry from, having a PhD level student come in and work with us in the company. Maybe it's more around, again, the structuring that program and understanding what's the requirement, right? Certainly long time ago when I was taking my PhD, I don't know that I felt I could spend 6 months to get away from my research work to work in a different project, right? So it might take more like, hey, we want to work on these together, which we actually do have. We fund a PhD student right now, but perhaps the question is, can you do that in our locations, let's say, and like a co-op, the PhD can get paid, right? So that's the other part. But all that can be arranged. I don't see any reason why there's a showstopper there.
Just jump in there with our consortium CB squared. Since we're NSF funded, NSF has supplemental funds to enable internships at our member companies. And so the company doesn't even have to pay for it. And it includes housing costs and everything.
All right. I would also encourage you, I'm not going to get to all these questions, but feel free to find the members of our panel afterwards if you'd like to follow up. All right. Maybe one last question. We'll work our way through here. So collaboration is difficult, and there's plenty of examples where collaboration doesn't work out. But if you look back into your experience, and maybe just a brief answer, what are the characteristics that really kind of stood out of successful collaborations, whether it's the people, the process, the nature of the project? If there's something that stands out where you can say, yeah, that's what made the difference on this collaboration. What was it? So we'll kind of work our way through whoever would like to go first.
I think just having very clear expectations and a lot of discussion. And I think that makes all the difference. The one that I'm thinking of that didn't work out as well as I wanted to was where the sponsor had very different expectations versus what I thought we had promised to deliver. And so that disconnect, just we never really resolved that. And but again, the other projects that have been successful, and again, even the ones where we've had to shift focus because certain things weren't working, is just having that flexibility, that dialogue, and making sure we really understood what we were planning to do.
Thank you.
I think a lot of success can come from communication, and I guess on the industrial partners side, we talk our own language, and we have a lot of base assumptions that the person we're talking to can understand all of that, and that's an error state. So taking the time, getting the investigators on the university side, like on site, if you're talking about a process in a plant, just seeing and feeling and like kind of living the process, or what we do, all sorts of terrible things, right, to materials and processes in our plants, and it would never occur to you, what all of those boundary conditions are, and we may assume you understand them, and on the other side they may not be aware of what we do. So success depends on that communication, and definitely effort made on the industrial partner side to clarify a lot of these processes, to take the time to share that knowledge or foundational understanding of the context from which we're coming, and then being humble and open to the new and maybe offbeat ideas that come back, and that's a successful partnership.
Just a quick note on that, because I think it's such an important point, the idea that you're working with somebody who doesn't have the same background in all different types of ways, but putting yourself in their shoes, I think that seems to be a prerequisite for success. So it's a great thing to bring up. Dr. Perez or Dr. Guo?
Yeah, I'm thinking, flashing back over the projects. I think for us, I would say it's always been successful because we always learn a lot of things, students and I myself. So even though certain projects we may not necessarily hit the final target, let's say, but our industrial partners are quite flexible. I think we don't have a really hard target. So yeah, it's been a very pleasure to work with the industries, and in my group I always encourage my students to have the opportunity to do internship, especially toward the end of their PhD, Because usually, you do three months internship, that's like, extended interview, right? Usually they can get a return offer right after that. And many of my recent graduate, that's what they do. They don't have to find jobs, sending a lot of resumes. So it's great for students. Yeah.
Thanks.
Mhm.
Dr.
I do agree. One of the key things for me that I've seen where the collaboration is successful is setting that expectation and making sure that both parties or all the parties are understanding what their roles are in delivering that expectation. If you don't have that clear upfront, then I don't see how you can be successful. And the second thing is, just really the effort and the time that you spend with each other. If you're the funder, you can't just say, oh, that's what I'm paying you for, because what you put in is what you get back out, right? So, and the other part, you mentioned this before in terms of speed. Innovation doesn't always come with speed, right? There's not always an answer, tomorrow, even if you expect an answer tomorrow. And just kind of reminded me of somebody put this up, so I'm going to steal it, right? That if you want to go fast, do it alone. If you want to go far, do it together. And I always think about that when I think about collaboration.
Well, that's a great way to finish off this this discussion. So thank you. So a round of applause for our panelists. And again, if you have questions, you can find them afterwards. Well, thank you. Thank you. We do have a quick announcement on the scholarship program. If Chinling would like to come up and the announcement.
Thank you, Kevin. Yeah. Yeah, my name is Qinglin Zhang. I work for BASF. I'm a committee member for the Focus Conference. On behalf of the committee, I have two announcements to make regarding how the society, the local society, is working with other organizations for collaboration. One, it's about working with another nonprofit company called ASM Material Education Foundation. The Detroit Society for Coatings Technologies is collaborating for the first time with ASM Materials Education Foundation to sponsor 3 teachers at a week-long hands-on materials camp. This particular material camp we are sponsoring is actually at University of Michigan Ann Arbor campus. So it's really good to serve the local community. The ASM program curriculum shows educators how to use applied engineering techniques in their classrooms. Materials camp is an idea generating workshop introducing teachers to methods that makes math and core science principles more enticing and relevant to their middle school and high school students. The ASM Materials Education Foundation mission is to develop and deploy material science content and hands-on, hands-on instruction strategies to inspire, engage, and empower future generations to create STEM solutions for 21st century challenges. We as a committee concur with their missions, actually want to introduce more coating-related topic to their curriculum. They agree to that. And we would like to really reach the student by reaching their teachers. Oh, sorry. The next one is about student research scholarship. The Detroit Society for Coatings Technology has initiated a research program, scholarship program for 2025 and 2026 to encourage and engage support from young scientists and engineers interested in advancing this field. We got 12 proposals from 5 different universities. The submissions were ranked on innovation, feasibility relevant to automotive coating industry, and how the research activity were designed. The selected students will give an oral presentation during next year's Focus Conference. It was really a difficult decision for us to select just one candidate to receive $10,000 award. The community has deliberated for a long time to select Lin Yue Zhu from University of Michigan. Her supervisor is Professor Jie Gu, who happened to be one of the panelists we just heard from. The project title is Continuously Tunable Structural Color Fabricated by a Controllable Copper 1 Oxide Nanocrystal Coating Technology. I understand Niamh is not here today due to a conflict, but congratulations to her and Professor Guo. All right.
Thank you very much. So it's break time now. I think we've got till what, 2:30 to the next talk? 2:25. So meet you in the break room with the exhibitors. Thank you very much.